I've been told where to stand and what to say. Staff tells me I have 5 minutes, so I will be quick. How this all started, and what you're going to see today, I think is really, really cool stuff. But it started one day when Manny came to me and said, I really could use some help with the research support group. I'm getting swamped. So we hired 2 students, and you see them here. And these guys helped Manny do the research support work. And one day, Manny came to me and said, you know, the guys have a few cycles in their day-to-day stuff. I'd like to try something. I said, well, as long as they get their day-to-day stuff done, I really don't care. That's super. And he said, yeah. So about a week later, he came to me and said, Ron, can I have $150? I said, why? I want to buy a Kinect box. I said, sure, Manny, sure. Play games all day. I said, yes, of course, because I know Manny, he wouldn't play games. He creates them, but wouldn't play them. So what you're going to see is the work that these 2 gentlemen plus Manny have put together. You're going to see 5 projects that have been developed using the Kinect box. And I'm hoping that what you will do today is when you walk away from here, realize what you may be able to do with this technology more than just what you see here. And I'm just going to give one example. For an example, you'll see a robot on the table. And you're going to see how that can be manipulated with this new technology. But think of it in broader terms. Think of it, how can it maybe move a pickup truck or a forklift truck or anything else. So when you're seeing what you're seeing today, because everything is in its beta stage, and it's clunky, and you'll see that, you know, it hasn't been refined, but that's beta version 1. Think of what you might be able to do with it, how you might be able to integrate it into your own research projects or into your academic courses or whatever. Okay? So I'll pass it on to Manny. Manny's going to run the show from now on. I'm just going to sit and watch.
I'm the guinea pig. So welcome. Basically, just to continue on what Ron was saying, these guys have been working for about 3 months developing software to take advantage of the Kinect device, which is this little guy up here. This usually is supposed to be hooked up to an Xbox game console, and a bunch of hackers on the internet found out that, well, you can actually hook it up to a PC and use it in other ways not intended by the original designer, which is an Israeli company. So the Kinect box is really simple. It's 2 cameras on top. So you got 2 cameras built in here. One's a color camera, one's an infrared camera. The infrared camera only sees infrared light. The Kinect, the color camera is just an average webcam, 640 by 480. And then the other thing that you have in here as well is what they call an infrared emitter, which emits a picture, if you like, of small little tiny dots of infrared. So what happens is that plane, that picture, sort of falls onto. It's actually falling on you guys right now. You just can't see it. It's falling onto Hesam. It's falling onto all this stuff that's here. And the device actually has enough smarts to be able to figure out where each one of those dots are in relation to each other and keep track of them. So as Ron was saying, we've developed 5 projects. Like, there's actually 6. The 6th one is really, really alpha version right now. So we're going to show them to you. There's 2 sort of tracks for the demonstration. The first track is basically how do we use the Kinect and the software that goes with it to control existing applications. So basically alternative interfaces into existing applications. Think no keyboard, no mouse. And then the second track, that has 3 demos. The second track has 2 demos. And then there we're going to show you how this could potentially interface with physical devices like this robot. And we also have another demo with the camera that we're going to show you. Okay, so the first demo I think is the mouse that we're going to run. It was our earliest prototype, first one that we started working with. And Hesam is going to do the, he's going to explain it. I'm going to be the guinea pig, so excuse me, I'm not being rude. I just have to stand in front of the camera and do stuff.
By the way, folks, this is Hesam and
Yes.
Wyatt.
Sorry, Hesam, Wyatt, these are the two students working for me, and that's Jeremy, who's been kind enough to volunteer his time to record this for us. So, okay, did you want to explain?
So yeah, this is our first project, first impression on the Kinect. We wanted to control the whole computer using the hand gestures or mouse, control the mouse, clicking or holding a button to actually move an icon or whatever you do, navigate through all sort of things. So as you can see, Manny can hold his hands to control the mouse wherever he wants. It's actually smooth, it's not that bad. And you can click or while swinging your hand towards out of your body. As you can see, he can click start and go to, I don't know, Google Earth or whatever application he wants. And also if he wants to move an icon, he just have to hold his hands beside his body and move the window or the icon or whatever he wants. So
as you can see, I'm moving the icon here, and for example, if I wanted to run the program, I would just click on it using my left hand. Not always the easiest. There we go. So hopefully soon. Now this machine's a little underpowered, so you have to give it a second.
It's also
kind of thinking. So I can actually, yeah, it's also Firefox. I can actually navigate using gestures and go to today's news.
So this was the good start for us to get to know the code. So we don't actually, we were familiar, we were getting to know the code and see where we can put the new code to actually embed those codes that we wanted to do to actually mix all together.
Yeah, so this was a good starting point. What we decided to do after this was to try to manipulate other software programs that might have a little bit more of a unique interface to them. So we also developed one for Google Earth.
Excuse me, I'm still in guinea pig mode.
So part of the issues we had when we were working with this was trying to decide what gestures actually should do what. Because after fooling around with it, we found out a lot of things that, you know, Hesam might have found normal for him were not what I thought should be done. So we had to come up with ideas that were a little bit outside of the box to let the program know and be able to let us know that we're actually trying to control the program rather than just kind of standing around doing anything.
Do a little dance, sorry.
You just kiss your hands, I guess.
So what Manny's doing right now, actually, how this works is we use pose tracking, and what happens is when he makes his pose, as you can see, it's calibrating to try to find his joints.
Manny, I guess you have to kiss him.
There we go.
So as you can see, there's two balls. So if the purple one or the pink one goes down, so he can control towards his out of the body or left or right to move the air, kind of thing.
So the teal ball is what controls the navigation up and down. And the idea we came up with here was because we had about 6 things we wanted to do, right? We had to determine what action did what. What we decided to do was separate them into hands. So this hand was doing the tilting of the earth. So tilt up, rotate left, rotate right. As you can see.
Or zoom in function with just swinging your hand inside or outside to actually zoom in the earth. The main problem here was that we don't conflict gestures to each other, so when you're doing this, it doesn't conflict with one hand up and one hand going the other direction.
It's also a good exercise.
Okay, so the next one is Second Life, and it's similar. We saw this, a lot of people actually, I mean, if you heard of World of Warcraft as well, they were doing this is just to control like a 3D avatar. And we saw some other people doing that. Actually, there was another group here at Ryerson, I think over at the DMC, that had initially tried some of this, and we decided that we might be able to do it better. And again, it was a good experiment in figuring out how to, again, control gestures. So as you can see, Manny, what happens in this one is when you put your hand between your torso and your neck, it gives you an area to work with. So if you go up in that area, you'll fly up. If you push your left hand or your right hand forward, you'll turn left or right. If you move your hands laterally outside the boxes, you'll go forward. Inside, you go backwards. And then again, you can fly up or down. So what we thought about this, all three of these programs we really thought could almost be implemented like a tablet where, you know, the pen is sort of your mouse interface for most things that, you know, it doesn't have a special interface for it. But for the other things, you can actually develop special gestures and customize them yourself, whatever you want it to be. So that this would be a good alternative to people that might not be able to use keyboards or mouse. All they need to do is use parts of their body to make it move.
So these are, is that the last one? Yeah.
Yeah.
So these three are basically ways of interfacing with existing programs. Okay, so basically we're not adding anything to the Second Life or the Google or the mouse for that matter even. We're just sending it commands the way it expects it. We just have an alternate interface in inputting those commands. So that was the first part, and if you have any questions, just interrupt me. Okay, sure.
What kind of users do you see for that? I mean, the mouse is easy to maneuver. Just
Right.
to stand there and do all that stuff.
If you're challenged, if you're physically challenged, this could be potential weight. The nice thing about it is it actually works even if you're sitting down. So once the actual skeleton is built or recognized, you can actually sit down. You can actually, we're working on trying to get it to initialize the skeleton while you're sitting down. So that could be a potential for someone in a wheelchair, for example, to be able to actually manipulate the computer or programs inside the computer just using simple gestures. And the nice thing about it is because you can customize the movement, you can actually get around physical disabilities, right? So if somebody can't, you know, move or raise their hands too far, you can actually program it so that, you know, over here is 0 instead of being over here kind of thing. So that gets around a lot of those problems. It is different, of course, than mouse and keyboard, which are the natural sort of ways of interacting with a computer. But I think this kind of opens up a whole new sort of paradigm for control. Yeah.
Could you see be scaled down to the movement of an eyelid for an ASL?
That's how the whole madness actually started.
Yeah.
We were at a brew pub with Vaughn and Brad just before Christmas, and what I pitched to them, which I didn't realize at the time what I was doing, was that we were going to use this originally to actually mount it in front of a person in a motorized wheelchair to be able to, using their eyeballs, to be able to move the actual wheelchair forward and back. And then we actually realized the limitations of the device in that it tracks skeletons and very rough areas of activity. So what we're working on now, the future of this, where these guys are going in the next 3 months, is a field called computer vision, and using a toolkit called Open Computer Vision toolkit. They're going to try to actually build a very small camera that's mounted inside a glass frame to actually be able to track eye movement using an infrared emitter inside, right, and an infrared camera that's basically just sitting right in front of you kind of thing. And you'll be able to do the same kinds of manipulations using your cornea, basically.
That's kind of where the robot playing came from, because before we got into manipulating actual wheelchair, we decided to start with something easy that had an Lenovo board on it that was easier to communicate with. So start off with this, but yeah, definitely the eye thing was what we originally had planned. So we're just sort of learning our way through the stuff right now and learning what works and what doesn't.
Yeah. So the robot, for example, is an example of manipulating like a real world device, and the communication between the robot and the computer is happening over Bluetooth. So it's kind of limited, but it's, you know, if the computer is actually on the wheelchair, if it's built into the wheelchair, it's not a problem at all. The limitation here is, I think it's a 30 feet distance limitation, but you know, you could replace it with Wi-Fi or whatever, something else in any case. So, okay, you're already running for it, so I'll sort of resume my guinea pig position.
So this is our other project which controls this robot. First, this actually started from where I wanted to actually detect a circle using your hand motion. So I came up with a circle thing that if all the, I don't know, spots gets a flag or something, it sees a circle and do something. So I talked to Manny and he said, why not to use this robot that we got already to control, navigate the robot. As you will see in the video.
Right.
Yeah, okay. So if
Just put your hand up, Manny.
No,
sorry, it's a better version. So
just hang on. We're gonna run it again. It always crashes on the first try.
Yeah, this one.
Sure. He's a better driver than I am.
You also figure out some of the tricks too of how long it takes to calibrate with it, because you have to have a pretty good position. So as you can see, sort of like a joystick idea here. We thought we would use to control it, but again, like this can be used anything: swiping left or right, hands up, hands down, foot up, foot down, whatever you like, really. This was just an experiment for us to figure out how easy it was to communicate with an outside device using the Kinect.
Poor thing. It doesn't have four-wheel drive yet. We're working on that.
Yeah. So we were able to get the communication down. All right.
So I think that's the second last one.
Yes.
Yeah.
The last one. This one actually was one of the first things we started on, but unfortunately we didn't have the hardware at first to utilize it, which was a camera that was able to move, have left, pan, tilt, zoom kind of thing. So Manny was telling me that a lot of times there's like, you know, you guys have webcasts or meetings, etc. over that, and you need to have someone set up the camera to track people and stuff like that, so that they're centered in the screen. So what I came up with the idea was to use the Kinect to actually track someone and keep them in the center. So we've got the Kinect tracking Manny, and we have it feeding information to this Canon camera, telling it to basically keep Manny in the center of the screen. So wherever he moves,
My skeleton.
there we go. So as long as the Kinect can see him, it will zoom, and it's actually feeding independently into another computer. So the two different color images are independent of each other. It's just the Kinect. So this software could work on any camera as long as it had the capabilities of moving. So the next thing that we came up with was that, you know, you might have a couple people in this meeting. They might want to, if you're doing a telecast or over the web. So what I did was, anytime a person was on the screen, if they wanted to take control of the camera and be the center of attention, they just raise their hand. Manny, if you want to, or Hesam just did it. So you raise your hand, and it starts tracking them. That, again, that could be changed to anything you want. One person could put their hand up, they could jump or whatever. The zooming is controlled because the camera is able to see how far you are, millimeter-wise, so we use thresholds, and the pan tilt is just, again, using the skeleton tracking thing.
So I could be moving independent of him. We actually tried this sitting down yesterday, like the three of us.
And it works well, yeah.
Lined up here, and once it detects you, it works really, really well. So for like a meeting or video conferencing where you normally have like 3 cameras just because you have 3 different positions kind of thing, this kind of setup would work really well. 'Cause, 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 Did you have a question?
No, just,
Oh,
just raise your
okay.
hand and come across view.
Right.
Yeah.
So, so basically, these are the other examples of sort of real-world manipulation using the data that the Kinect provides. We have one more application that's kind of half-cooked right now. We kind of came up with it. Myself, Ron and I sort of saw what Hesam was doing one day, and he was actually playing around with that donut-shaped thing that we used for the robot. And he was changing letters on the screen, so as he kind of scrolled through the alphabet, and he could move the alphabet on the screen by using his other hand. And I said, well, geez, wouldn't it be a great idea to have like a phone book like that? You know, where you could sort of just manipulate something, you know, like a keyboard or go through letters or something like that, push a button or do a gesture to actually do a phone dialing, right? And we have parts of it kind of functional, so you just have to sort of use your imagination to put together. So if you want to run that,
Just,
yeah.
Put your hands up for a second.
Oh, yeah, right, sorry. So this is alpha, as far as the beta codes are concerned.
Yeah, we just kind of working on
we just got it working like,
a few days ago on it. So.
yeah. So,
Well, man, you got put your arms further back.
there.
It's just like lifting some weights.
Okay.
Go out of the picture.
Yeah, go on the picture.
Wyatt.
Yeah. Okay, so here, did you want to explain this, or? Did you
Yeah,
want me
this
to-
is like a keyboard. So we made a keyboard so we can use it later on for something else maybe too. So you type in something. That's a backspace. That's a del button. All the alphabets are there. So if you type manu or M, it will show up the three you didn't punch.
Oh. Yeah,
If you didn't
right.
find it, it will show all the names or whatever it has. If you type just M and put your hands up kind of thing, it will show the first or whatever it had. It starts with the M. It's
And
kind of
yeah.
alpha. It's not done yet, but it's kind of the same idea with the mouse. Whichever hand is forward, it's a selecting hand. So if you swing your hand, it actually selects the word, and it searches for certain thing you entered there.
So as you can see, it's still sort of finicky with selecting letters because again, it's the big problem with this is trying to determine what's a gesture and what's not. Sometimes those two things get confused. Anyways, something that can tie in with the rest of our
Yeah,
program.
so the idea here is, and I'll show you, so you got to make a mental jump here from that to, do we have this open here? Google Talk. Sorry, where is, so, I don't know if you've seen this, but Google has now the ability to, using a computer, to dial a real phone number. So, and it's free, which is kind of cool. So I'm just calling my own cell phone. Did I dial the right number? Yes, I did. So that's Google calling me. Hello? Yeah. So I can hear myself. Basically what we're trying to do is connect that part of the program to this API and be able to just select the person and have the number automatically ready. So when you do a gesture, it will just dial the number for you. So that could be an interesting application potentially for an alternative interface to computing.
And I know you've seen a lot. It's just been the skeleton, and we've been calibrating that. And, sometimes that's a pain, but there are other options out there. We have another thing where it's hand tracking, where you wave your hand, and it just tracks your hand. You don't have to do anything else but wave your hand or push it forward. That's sort of still being worked on. It's not as exact as the joint tracking kind of stuff, but it's still. I mean, if the calibrating thing is something that maybe is not possible, there's a lot of different options out there. It's just something we've been working on because it's a lot more precise and refined than the rest of the stuff out there right now.
So the computer vision library that we're eventually going to get into now has the ability to actually track faces and differentiate between faces. So it has face recognition built in as well. So you could do things like, have pre-assigned cameras so that when somebody walks into the room, it actually recognizes the person and knows, what channel they want to, chat on, for example, or, things like that. In addition to be able to track them and all of that. And what that enables you to do is basically get rid of this device up here. So you don't need this anymore because you already have data, the tracking, the picture data, if you want to call it, from just any old webcam at that point, right? As long as the webcam can be moved around using some sort of serial communication, you can do this, right? So that's been our demo. If you have any questions, if you have any questions, please feel free. If you want to try out some of them, we can set it up for you. Just if you want to play around, just to see how responsive it is.